All right, let's get started with 3.4. I'm going to explain what these P's and C's are about in just a few minutes. Okay, so let's say we were picking teams and we had Bob, Ellen, Kylie, and Jeff to pick teams. For the first set, we're going to pick a president and a vice president. So the order matters, right? So in this first column, we're going to go ahead and let Bob be the president. Bob could be the president with Ellen as the VP, or with Kylie as the VP, or with Jeff as the VP. Okay, then the second column, we're going to let Ellen be the president. So notice Ellen and then Bob is different than Bob and Ellen because we're now going to let Ellen be the president. So Ellen can be the president with Bob or with Kylie or with Jeff and so on. Then we let Kylie be the president. We let Jeff be the president. So notice when order matters, I have 4 people I'm picking from, but I actually have 12 different ways that I can pick. This is called a permutation. If order matters, we're going to call that a permutation. Our calculator is actually going to do the work for us. We don't have to sit here and pick them all because that would get really crazy if we had like 10 people and we were trying to pick, it would get awful. So the calculator is going to do that work for us. I'll show you that in a few minutes. But that's when order matters. Now let's say that the order doesn't matter. Okay, let's say we're just picking 2 people to go to a conference. So it doesn't matter that I pick Bob first or Ellen first. So with this first one, once I pick Bob and Ellen together, I don't have to also pick Ellen and Bob, right? Because they're already together. So we're going to let Bob and Ellen go to the conference, Bob and Kylie, Bob and Jeff. So when I get to the next column, I'm not going to do EB because Ellen and Bob already have an option above, but I do need Ellen with Kylie and Ellen with Jeff. And then that next column, Kylie and Bob were already picked up here. Kylie and Ellen were already picked here. So I do need Kylie with Jeff. I don't need that whole last column though, because Jeff and Bob were already picked together. Jeff and Ellen were picked together and Jeff and Kylie were picked together. So notice the number comes down. When the order doesn't matter, I only have 6 choices. So this is combination, right? And so we would say 4C2 because we're picking 2 people out of 4, but we're not worried about the order. All right, so first we're going to look at factorial. Factorial looks like an exclamation point. It is, but it has a different meaning in math. What it means, let's say I give you 4 factorial. That means I'm going to just start multiplying backwards. So I'm going to have 4 times 3 times 2 times 1. And that would give me 24. Notice up here, I could do 10 factorial, right? That would be 10 times 9 times 8 times 7, all the way down to times 1. We don't want to do that. But look at how big these numbers are getting. So on our calculator, if you hit the shift button and then hit this button over here, it looks like it's x to the -1 power, it is, and it has the x factorial above it. Okay, so you're going to put your number in first. So in this case down here, you would put the 4 in first from the keyboard, then you would hit shift and x to the -1 power. That's going to give you the factorial sign. Hit equal, and you'll get the 24. Okay, so permutation is when order matters. And the way I remember it is that the O and the P are next to each other in the alphabet. So permutation order matters. That's really important. Again, we're going to let the calculator do the work. But with this one, they said each grid in a Sudoku number puzzle has 9 boxes in it, right? So the grid up here has 9 boxes in it, and you can't repeat. So we did a little of this earlier in this chapter. Once you put a number in a box, you can't use that number again. And so we have to fill up 9 boxes. For the first box, we have 9 choices because we can do 1 through 9. But once we pick a number, now we only have 8 choices. Once we pick that number, we only have 7 choices and so on. But instead of putting all of this in our calculator, 9 times 8 times 7 times 6, we can just put 9 factorial. In the calculator, it'll do it for you. Look at that. It's 362,880 different ways. That's why Sudoku is so frustrating. My dad loves it, but not me. Okay, so when we do these problems, we are going to ignore, help me solve this. We're going to ignore this formula up here, and we're going to let our calculator do the work. If you look on your calculator, right above the multiplication sign and the division sign, you see a little yellow NPR and NCR. So what that means, since it's yellow like that, is you're going to have to hit Shift and multiply to get NPR. You're going to have to hit Shift and divide to get NCR. So this says find the number of ways of forming 4-digit codes in which no digit is repeated. Okay, so we're picking 4-digit codes, but we're for digits, we get to use 0 through 9. So 0 through 9 means that I have 10 choices. So in my calculator, I'm going to type 10. Then I'm going to hit Shift multiplication. That's going to give me P. So that's for NPR. And then I'm picking 4. You can't do this backwards. If you put 4P10, it's not going to work. You're going to get an error. So once I hit equal sign, I see that there's 5,040 ways to pick 4 digits out of 10. And of course, order matters because we're doing a code, right? Code, password, all of those, order would matter. So we use P. Okay, on this one, we've got 33 race cars start the Indianapolis 500. I think the car races are starting this weekend. How many ways can the cars finish first, second, or third? So we're picking 3 out of 33. And order matters because we're looking at first, second, or third. So if you put that in your calculator, don't worry about this. This is StatCrunch. Use your calculator. If you put it in your calculator, you're going to type the 33, hit Shift multiplication to get the P, put 3, and you see that you get 32,736 different ways that 33 cars can come in first, second, third. It's crazy, isn't it? Okay, some of the homework problems are really quick and easy. They give you 54P2. You put it in your calculator and you get 2,862. Okay, so distinguishable looks a little bit different, but it will have that word. So the problem will literally say distinguishable, and that's how you're going to know to use this formula. What happens is you're going to use the total number. I'm going to show you a problem in a few minutes. You have the total number on top as a factorial, so this 10 factorial, and then you have the other numbers underneath. But with the Casio, you have to put the multiplication symbol in there. So you're going to hit your fraction key, which you know how to do. You're going to put the 10 and then hit Shift and X raised to the -1 power. On the bottom, you're going to do the same thing. You do 2, hit the factorial, times 3, and hit the factorial. Okay, so we've got a building contractor who's planning to build a subdivision. The subdivision is to consist of 6 one-story houses, 4 two-story houses, and 2 split-level houses. In how many distinguishable ways, see that word is there, can the houses be arranged? Okay, so here's what happens. We have to have the total on top, right? So the top has to be the total with the factorial. On the bottom is going to be the pieces. I can't spell pieces. So we need to add these up. 6 plus 4 plus 2 gives me 12. So I have 12 factorial on top. On the bottom, I have the 6 one-story times 4 two-story times 2 split level. Okay, so those numbers need to sum to the number on top. Then you pop it in the calculator and you get 13,860 different ways. Isn't that crazy? You have 12 houses and you have that many different ways that you could lay them out. All right, one more. The contractor wants to plant 6 oak trees, 9 maple trees, and 5 poplar trees along the subdivision street. The trees are to be spaced evenly, and how many distinguishable ways can they be planted? Okay, so we know on the bottom we've got our 6 oak trees, 9 maple trees, 5 poplar trees. If I add those together, I get the 20 total. That's what goes on top. Put that in your calculator and look at that. That is like almost 78 million different ways. That's just crazy. All right, with C, with the combination, it's that the order doesn't matter, right? Population, the order matters. Combination, the order does not matter. We're not going to worry about this formula because the calculator is going to take care of it for us. So the hardest part is just reading the problem and see if order matters or it doesn't matter. So with this one, the state's Department of Transportation plans to develop a new section of interstate highway and receive 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the 16 bidding companies? All right, so we're picking 4 out of 16. We just need to figure out if order matters, but it doesn't sound like it. It doesn't say that the first one's going to make more money. There's no words about order. So we're going to go ahead and do 16C4 because order doesn't matter. Put that in your calculator and you'll see that you get 1,820. And that's because order does not matter, that it's a much smaller number. All right, we have a manager of an accounting department wants to form a 3-person advisory committee from the 20 employees in the department. And how many ways can the manager form this committee? So there's no words about a president, a vice president. There's no words about order. So we're going to go ahead and do a combination. We'll do 20C3 because we're picking from 20 employees and we're only picking 3. So we've got a combination. So when you go into Lowe's to buy a combination lock, you tell them that this is not really a combination lock because order matters, right? As the number matters on a combination lock. Tell them it's a permutation lock. They'll probably escort you out of the store. Okay, so here's just a little review of counting principles. We had the fundamental counting principle. That's when we were looking at different kinds of cars, so different makes, different sizes, different colors. We just multiplied. Then we have a permutation. So permutation is that order matters, and we're going to use our calculator. Of course, if we have a factorial, we're going to use our calculator. Distinguishable, we're going to use our calculator and be really careful that we have the multiplication symbol on the bottom. And then finally, if order doesn't matter and we're picking, we're going to use combination. Okay, so a class of 34 students. We are going to pick 5 students to form a group for an activity. It says the order of the students is not important. Okay, so that was nice. That means that I have a combination. So I am picking 5 students out of 34. Put that in your calculator and whew, you get 278,256 ways to pick students for a group. All right, decide if the situation involves permutations, combinations, or neither. Explain your reasoning. The number of ways 13 people can line up in a row for concert tickets. Okay, so in class, we usually have a lot of discussion about this, but I figure if you're lining up, order matters because if they try to give a ticket to the 13th person and I'm the first person, I'm going to be really upset. So we're going to say that order matters and that means it's going to be a permutation. Okay, here we have a student advisory board, consists of 17 members. 3 members will be chosen to serve as the board's chair, secretary, and webmaster. Okay, so order matters because they're going to be put in positions. So we want to know the probability of randomly selecting the 3 members who are already in the position to be chosen for the board again. I know it's really not worded that way, but that's what they're asking for. So first you have to do 17P3. So you're picking 3 people out of 17. We're not going to do all this craziness. We're going to put it in our calculator. And that gives us 4,080. That's my denominator. Okay. And then the probability of selecting the 3 members who already hold each position, that would just be 1 because that's one set of 3 people. And so for the probability, I would have 1 over 4,080. All right, so now we're getting a little trickier. We want to find the probability of being dealt 5 diamonds from a standard deck of playing cards. So I know this is going to look a little crazy, but what we want is we need to put the number of ways of picking the 5 diamonds out of 13 diamonds over the probability of just picking 5 cards out of 52. Okay, that would be our total. So what we're going to do here, if we're picking 5 diamonds out of 13 diamonds, that means that I would have 13C5. It doesn't say anything about order, so we're going to use combination. So on top, that is picking 5 diamonds out of 13 diamonds. On the bottom, my total, I'm going to pick 5 cards out of 52 cards. Okay, put that in your calculator just like that, and you will get the answer. Right, so this one is the same idea, just to get a review. So the offices of president, vice president, secretary, and treasurer for an environmental club will be filled with a pool of 15 candidates. So I have 15 total people. 9 of the candidates are members of the debate team. So 9 are on the debate team. That means that 6 are not on the debate team. And I am picking 4. So order matters because I've got president, vice president, secretary, and treasurer. So the first one says, what is the probability that all of the offices are filled by members of the debate team? Well, if they're all filled from the debate team, then I would have 4 members out of 9 members, right? Because there's 9 members on the debate team. But since this is a probability, I have to put that over picking 4 members out of everybody. So I have 4 members being picked out of the 9 debate members. And on the bottom, I have my total. So 4 looking at 15 and picking 4. Okay. Then B is find the probability that none of the offices are filled by members of the debate team. So that would be, they would all come from my 6 that are not debate team. So I would have 4 picked out of 6 over my total of 4 picked out of 15. Okay, so sometimes we're not picking all from debate team or all not debate team. So we're going to use this one. So we have a food manufacturer is analyzing a sample of 40 corn kernels for the presence of a toxin. In this sample, 3 kernels have dangerously high levels of toxin. 4 kernels are randomly selected from the sample. What is the probability that exactly 1 kernel contains a dangerously high level of the toxin? Okay, so here's what happens. We have in this sample, we have 400 corn kernels. They somehow know that 3 have the toxin. So that means 397 don't have the toxin. Does that make sense? Hopefully. So 3 have the toxin, so that means the rest don't have the toxin. So we want to choose, we're choosing 4, but we want 1 to be out of the 3 toxic, and we want wait a minute, I did something wrong. The remaining 3. This should be 3. The remaining 3 are going to be chosen from the 396 non-toxin. Okay, so here's what's happening. I have 3 toxic in the sample, right? And I want one of those. I want to pick one of those, right? They told me that up here. Then I have 397 not toxic, and I want to pick the rest of my 4, so that would be 3 of them from that one. And then in the denominator is everything. So the 400 kernels, and I'm picking 4. So here's what happens. You have to make sure that your first number of 3 and 397 equal the 400 down here. And then you have to make sure that what you're picking matches too. So you have 1 here and 3 here. So 1 plus 3 gives me the 4. All right. So one more time. The total is that we're picking 4 out of 400. That one's not so bad, right? So I'm picking 4 kernels. 4 kernels are randomly selected from the sample of 400. That's what's down here. But then they got picky. Of those 4, they want 1 to be out of the 3 toxic. So that's my first part here. And then they want the rest of them, we'll get rid of this, the 3 are going to be from the remaining that are not toxic. And then you put that in your calculator and you get 0.030.